The signal from the stars, the discovery. For thousands of years, humanity has lifted its gaze toward the night sky and whispered the same timeless question. Are we truly alone in this vast universe? From ancient tribes etching constellations into stone walls, to philosophers debating the existence of unseen worlds, to scientists crafting instruments of unimaginable precision, this question has followed us through every era of human history. It lingered like an echo across centuries, a quiet call from the cosmos that refused to fade. Science gave us probabilities, mathematical models, and beautiful theories. We calculated the chances. We imagined countless possibilities. But what we did not have was certainty. We did not have proof. Until now. Just 120 light-years away, an enormous distance by human standards, yet a near neighbor on the cosmic scale, a faint red dwarf star burns quietly in the constellation of Leo. Orbiting that star is a planet unlike any we have seen before. That planet is known as K2-18B. And thanks to the golden mirrors of the James Webb Space Telescope, humanity may be closer than ever to an answer it has searched for over millennia. When Webb turned its infrared eyes toward this distant world, the results astonished scientists. The planet's skies did not resemble the sterile, lifeless atmospheres we have observed so many times before. Instead, Webb detected a cocktail of molecules that demanded attention. There was water vapor. There was methane. There was carbon dioxide. But alongside these familiar chemicals came something that should not exist on a barren, lifeless rock. A fingerprint of biology. Dimethyl sulfide, DMS. On Earth, this compound is not created by volcanoes, storms, or geology. It is made almost entirely by life itself. Tiny phytoplankton drifting in our oceans release it into the air as part of their natural cycle. To discover this molecule on K2-18B was nothing short of extraordinary. For the first time, the search for life was no longer just an elegant theory. It became chemistry. It became biology, written directly into the skies of another world. And K2-18B is no ordinary planet. It belongs to a rare class scientists call Hycean planets, worlds wrapped in thick hydrogen atmospheres, possibly concealing immense global oceans beneath. Picture it. A world 2.6 times larger than Earth, with nearly 9 times Earth's mass, orbiting close enough to its star to keep liquid water alive. Not a desert like Mars. Not a storm giant like Jupiter. But a balanced ocean world, a world that could nurture life. Even more astonishing was the detection of another compound, dimethyl disulfide, or DMDS. On Earth, DMS and DMDS rise together only from ecosystems in the sea. To find them both, alongside water vapor and carbon chemistry, was statistically extraordinary. The signal was so compelling it forced scientists to pause, check and recheck their data, and then whisper a word they had long been afraid to speak: life. Cambridge astrophysicist Niku Madhusudan, who led the research, called the moment a watershed in history. For decades we speculated, she said. But now, for the very first time, we may be detecting molecular signatures inseparable from living organisms. The implication was staggering. If life truly exists on K2-18B, what form might it take? Some scientists imagine a world much like Earth billions of years ago, an ocean planet brimming with microbial activity, a biosphere at the dawn of its story. Others imagine stranger possibilities. With lower gravity and a dense hydrogen atmosphere, life might evolve in shapes and forms we cannot predict. Perhaps filter-feeding organisms drift through alien seas, gathering nutrients like great sails in the current. Perhaps pressure-tolerant beings live both in the deep oceans and the skies above. K2-18b may not mirror Earth as we know it today. It may instead reflect Earth's earliest chapters, life in its very first act, writing the opening line, the questions that follow. But discovery did not end with chemistry. It opened a door to questions more profound, more unsettling, and more human. If this planet is alive, should we reach across the void? Or should we remain silent? Some researchers urge restraint, warning that broadcasting signals could disturb or destabilize a fragile biosphere. Others caution that announcing ourselves might expose us to dangers we cannot yet imagine. Yet voices like Avi Loeb counter with a different view. If advanced civilizations exist, they already know we are here. For over a century, Earth's radio transmissions have leaked into space, rippling outward like waves in a cosmic pond. If someone was listening, they may have already heard us. But even if they did, communication across such gulfs is painfully slow. A single message from Earth would take 120 years to reach K2-18B. Another 120 years would pass before a reply returned. 2.5 centuries for just one exchange. So the debate is not only about technology. It is about philosophy. Should humanity remain a quiet observer? Or should it boldly announce its presence to the stars? When Webb's findings became public, the response was electric. News outlets flashed headlines across every continent. Social media erupted with hashtags like #K2-18B and #AlienOceans. For the first time in living memory, humanity looked upward together, united not by conflict or politics, but by wonder. Children asked their teachers about telescopes and distant planets. Space agencies quietly rewrote their roadmaps, planning missions to probe alien atmospheres. Private companies whispered of AI-driven probes and interstellar capsules, technologies that, just months earlier, belonged only to science fiction. But with wonder came shadows. If life thrives on K2-18B, then perhaps it flourishes on countless other worlds. And if it flourishes elsewhere, why have we not seen it? This is the paradox at the heart of our search. The Fermi paradox. A universe seemingly full of opportunity for life, yet silent when we listen. Perhaps civilizations burn out quickly. Perhaps intelligence is fragile. Or perhaps silence itself is a strategy for survival. If microbes are all we ever find, that alone would be profound. But if one day we detect organized ecosystems, or even structures hinting at intelligence, then perhaps the silence of the universe will prove to be its loudest warning. Speak carefully. K2-18B also forces us to expand our definition of life itself. On Earth, organisms rely on oxygen, carbon, nitrogen, and liquid water. On K2-18B, hydrogen dominates. Could creatures there breathe hydrogen? Could photosynthesis exist beneath the dim red glow of its star, instead of the bright yellow light of our sun? To explore this, scientists study Earth's extremophiles, organisms that thrive in boiling acid, frozen ice, crushing pressure, or radiation. Once dismissed as bizarre exceptions, they are now seen as blueprints for alien survival. It also makes us reconsider mysteries of the past. Strange crystals. Unusual residues on meteorites. Microscopic patterns we once ignored as anomalies. Perhaps these were whispers of life, messages we were not yet ready to understand. Before K2-18B, we gazed outward with curiosity. After K2-18B, we gaze outward with responsibility. Psychologists warn of a coming, cosmic shock, the moment when humanity finally accepts Earth is not unique. Religions revisit creation stories. Philosophers ask what this means for human purpose. Educators prepare to teach a generation that may grow up knowing life exists beyond Earth. Some feel awe. Others feel fear. Few remain indifferent. K2-18B is more than a discovery. It is a mirror. A reflection of who we are, who we were, and who we might become. For centuries, we believed life was a lonely spark flickering in the dark. This finding changes that belief. It arrived not as thunder, but as a whisper. A whisper that life may not be rare, but instead a pattern woven into the fabric of the universe itself. And that whisper does not end the story. It begins a new one. It asks questions we cannot yet answer. Are we truly alone? Do we remain silent? Do we dare to reach out? Or do we wait, patient, careful, for the universe to whisper again?